Hey folks, this is Ben. We'll start in just a minute or two. I've just been chatting with Bassam and he's going to get set up. Okay, we'll get started in just a minute or so. Morning, Chris.
Hey, how's it going?
Can you guys hear me okay?
Yeah, loud and clear, Bassam.
Okay, great.
So I'm just pulled up the minutes too. If folks want to add themselves into the minutes, I'm updating the page right now in terms of attendees. And then I'd also just like to hold space for just a second so people can share if they've got topics that they want to be discussed or talked about in the SWG, in the storage working groups. If anyone has those, now is a good time to mention them.
Could you post a link to the minutes in the chat?
Yeah, I'll do that right now.
Yep, we'll do that, Mike.
Thank you.
Yep. Okay, so I think next week, or sorry, next time, we're going to try to have the OpenSDS guys present and talk about what they're doing from the storage space. It'd be good to make sure we understand what's happening there too. But I'd love to hear more topics. And if there's not enough topics, then we'll change the cadence of the meeting from every 2 weeks to maybe every month. So if you have topics, please share them with me.
Can I make a request that we link to the minutes doc in the meeting invite?
Sure, I'll do that.
Thanks.
All right, thanks, James. Okay, so today we're going to have Bassam talking about Rook. It's a project that the CNCF is actively looking into, and I wanted to bring it to the Maybe you're not.
Hey, Ben, I can't hear you now. You just disappeared.
Can folks mute if you're not talking, please? Okay, great. I wanted to bring this project to the storage working group so that we could do a deeper dive and understand it in more detail. And so this is an opportunity for Bassam to present, as well as then for us to ask lots of questions. So looking forward to it. Bassam, you can go ahead.
Excellent. Thank you, Ben. Thank you. I'm assuming you can all see my screen, my slides. So,
Yep.
and I'm planning to do a demo, and I'm hoping that screen share will work for that too. So, hi, my name is Bassam. I'm the CTO at Quantum. We started this project called Rook. Rook essentially is a storage orchestrator for cloud native environments, and I wanted to kind of walk you through it and hopefully you'll get all sorts of questions and feedback on the project. So just a quick overview. Rook was open sourced in November of 2016. It's under an Apache 2.0 license. We started this project essentially so that we can get storage working in a cloud native way on top of cloud native environments. So the Rook takes distributed storage software, think Ceph, or in the future it'll be Gluster or others, and then orchestrates them so that they could run really well on top of cloud native environments. Essentially turns them into self-managing, self-healing, self-scaling services, properties you expect out of a cloud native service. And it does this by automating deployments, bootstrapping, configuration, provisioning, scaling, all the things that if you're running as a service, you expect to be done for you. Rook attempts to do all of those things in software and by leveraging the cloud native container management system, the scheduler, the orchestrator, to actually perform its duties. So one way to look at it is that Rook uses cloud native environments to run a highly, reliable and scalable storage services. The other thing that Rook has done is it integrates deeply into the cloud native environment. We focus today on Kubernetes, but we integrate pretty deep. Can somebody mute? I think, or not. If you're not talking, would you? All right. Can you? So Rook integrates deeply into cloud native environments, leveraging extension points. The goal there is that we are trying to provide a very seamless experience with the container environment. Almost think of storage as being a built-in, an extension of the cloud native environment. So things like scheduling, lifecycle management, resource management, policies, security, including RBAC. We try to not create another layer, but instead leverage the cloud native environment's facilities for those and just make storage be an extension point of those. So we've started out with orchestrating Ceph for Kubernetes. We've had a bunch of people ask us to do more, and we're hoping that the Rook project could be used for orchestrating other storage systems on many more different orchestration environments. And hopefully we can get community help with that as well. The project's currently in alpha. A beta is planned for the fall, and we hope to be production ready by the end of this year. So pretty accelerated schedule. And I'll say part of it is that because we are not building a new data path, we're not creating a new storage system, we're orchestrating battle-tested existing storage systems. Make sense? Any questions at this point? I think what I'll do is I'll just pause and have people ask questions. I welcome a very interactive session, but I'm happy to also move on. Okay. So just to kind of motivate why we're doing this and kind of walk through a couple of use cases and kind of understanding, and then I want to walk through a demo and give you a little more status on the project. So we started looking at storage and running storage in top of cloud native environments, whether it's Kubernetes or Docker or Mesos or others. And just as kind of a starting point, we realized that most of the container native or cloud native environments treat storage systems as an external thing. They're not part of the environment. They're not, say, as we treat containers or as we look at networking, where we make those first class. Storage is an external entity. There's a lot of focus, including in this working group, around how to interface to storage systems, CSI being the project for that. But storage services themselves are still external. So if you look at this diagram and on the left is our cloud native environment. On the right is the actual storage service or the storage software. And your choices are, if you're running in a cloud environment, it's whatever Amazon or Azure or Google provide there, S3, EBS, and equivalents. Or it's open source software that you have to essentially run yourself, or it's traditional enterprise storage. Think of boxes that provide some kind of storage, or NFS, or whether it's NFS or SAN or whatever the interface is. And so we asked the question, why is storage outside the cloud native cluster? And from that perspective, if you look at a use case, if I wanted to run something like GitLab on, say, Kubernetes, and let's start with on-premise. Well, I mean, there is a Helm chart for GitLab. It's really great. I can deploy it really quickly. It comes up. I get all the amazing features of pod failover and allocation of resources and resource management. Networking kind of works. All of this stuff happens, but GitLab requires some durable, persistent storage for both the Postgres database as well as the actual Git data itself. And so I essentially fall off a cliff in that scenario. I have to go figure out how to provision storage outside of the cloud native environment. And then whether it's a Ceph cluster or a Lustre, Gluster in the open source world, or it's something else on premise, I don't have S3 or EBS on premise, which means that I have to figure out how to do security, scheduling, availability, backup and DR story, upgrades, migrations, monitoring, all of those things that are required to actually get storage to work well to support this use case happen outside of the cloud native environment. And even if you think about running GitLab on, say, Kubernetes on inside AWS, AWS as a service, I get storage services. They run as a service. So I get EBS and I get S3 and I get even EFS from a storage standpoint. And with dynamic volume provisioning, say in Kubernetes and volume plugins and the path to CSI, the cloud native environment can actually provision storage pretty nicely in these environments. But I still don't get the integrated security and integrated scheduling and even quality of service. When I start to think about multi-cloud and federation, it's kind of I fall off a cliff again. And so, and then there are pretty, the experience in terms of running a dynamic environment such like Kubernetes in a place like AWS, you start to see kind of cracks in the seams here, or cracks in the story, where storage actually is not as dynamic as, say, the cloud native environment is. I'll show you a couple of examples just to kind of illustrate this. So on the left, if I was looking at a pod failing over in an availability zone with EBS, Kubernetes does a good job at provisioning EBS with dynamic volume provisioning. So when a pod failover, it could take up to an hour for the EBS volume to detach and then reattach to the pod. So while we spend all this time and energy trying to make failover of pods and containers be super quick and super efficient, because storage is external, it could take up to an hour for this failover to happen. So the bottom chart here shows gaps in a Prometheus chart where it's up to an hour for it to come back alive because it's running on EBS. And on the right, you can think if I was running a cluster across availability zones, well, if I wanted to fail a pod over availability zones because I'm building an HA app or service, an EBS volume does not fail over across zones. So I'd have to take a manual snapshot of it or have some automation outside of this environment, send it up to S3, and then do essentially a restore from that, create a new volume from that snapshot in the other zone. And that's all done outside of the cloud native environment, right?
Bassam, this is Steve Watt from the Cube Storage Site. I agree with the multi-availability zone. I think the single availability zone is artifacts of a bug, series of attach, detach, synchronization issues in Cube 1.6 that I think you'll see is largely fixed in Cube 1.7. We hit this a lot in OpenShift Online as well.
Yeah, even outside of a Kubernetes environment, attach, detach cycles take a long time with EBS, even if you don't introduce Kubernetes. It really depends on the size of the volume or provisioned IOPS and what's the noisy neighbor problem and what's currently happening in the environment. So I think there's definitely improvement on the Kubernetes side, but I think this problem is actually independent. Okay, so then that leads us to why don't we bring storage into the cloud native cluster? I think storage services themselves, storage software themselves are distributed systems. Cloud native environments are really good at orchestrating and managing distributed systems. At some level, you could argue that this is a great marriage of some sorts. And so why don't we run the storage service itself on top of cloud native environments using the scheduler, using the resource management facilities, using the failover facilities to make the storage system to run more like a service and make it essentially and integrate it deeply into the environment. And so that's what motivated Rook. And so I'll just switch to a demo because I think that will become very obvious when you see it. So let me close this. So what I have here is a 3-node Kubernetes cluster, and I'm just going to demo running Rook on it. It has literally nothing on it at this point. So let's see. So I have the first thing I'll do is we'll install the Rook operator. So think of the operator as essentially an extension point of the cloud native environment. It's how we add essentially a controller that is going to manage storage in this cluster. This is a one-time operation. You do this once per cluster. And at that point, you have all the facilities for storage available to you. So I'll start there. Let me just cut and paste the operator YAML. And you'll see that a pod gets started with the Rook operator on it. So there is the Rook operator. And at this point, I can go ahead and create clusters and I can create virtual pools and use them in all sorts of interesting ways. So let's start by creating a new storage cluster. So here's the YAML for a storage cluster. I can specify the name of the cluster and the namespace it goes in. I can specify the actual version tag of Rook to use. In this case, we're just going off of master. And then I can specify a set of properties that help me identify nodes, storage nodes, or nodes that have certain kinds of storage, and I can filter them in all sorts of interesting ways that make up this storage cluster. So I'll just leave the defaults for now and go ahead and create the cluster. So when I create the cluster, notice I'm using kubectl. There's no Rook API here. all my interactions are going to be with Kubernetes. What happens is that the Rook operator notices that I wanted to create a new cluster. The cluster itself is an API object or an extension object in Kubernetes. The Rook operator sees that there is a desire to create a new cluster, and then it actually goes ahead and starts the process of orchestrating a new cluster. So you'll see a bunch of pods come up in the namespace. In this case, we're orchestrating Ceph, so you'll see the Ceph monitors, 3 of them come up. They get bootstrapped, they get put in a quorum. We wait for that to happen. We check the health of it. The operator's doing all this work. It starts the storage nodes, the Ceph OSDs. It configures them appropriately, essentially bringing up a cluster that, because I've specified all the storage nodes here, brings up a cluster given the resources available and working very closely with the orchestrator, or the Kubernetes API and the scheduling and resource management facilities available there. So now that I have a cluster, let's actually go ahead and use it. I'm going to go create a pool, and a pool is essentially a virtual pool that specifies replication or erasure coding, redundancy, and other parameters. So I'll go and create, we'll call it a replica pool. And it'll be in the Rook namespace, and we'll just for now we won't do anything fancy. I'll also create the concept of a storage class in Kubernetes. And storage class is essentially a class of volumes that Kubernetes can provision. And you'll see here, I associate the storage class with the pool I want the volumes to be created in. So we'll go ahead and do that. And again, this is dealing directly with kubectl, so I'm doing all this work inside Kubernetes. And at this point, the operator will go and pick up my, the desire to create a pool, and then go configure the pool within the Ceph cluster itself, setting all the parameters, doing all the whatever is needed to get that working. And we're essentially done. I created a pool, and now I can use the pool. I can use it to dynamically provision volumes within this cluster. So let's do that. Let's go fire up WordPress. So I have a YAML here for deploying WordPress, and I'll show you. From this point onward, we're just using the facilities for persistent volumes and and dynamic volume provisioning inside Kubernetes. So as you're familiar with WordPress, WordPress uses MySQL to actually does all the persistence inside a database. But WordPress also has persistent store underneath it for, content and HTML content and everything else. And so we'll see that, if we look at this, that there's a persistent volume claim for MySQL, and then there's and it's set to be 20 gigabytes, and the access mode is read-write once. And here's where we say that we want to use Rook. So we specify the storage class for where we want this volume to be created. And again, that's how we derive the pool settings and replication or erasure coding or everything else that comes through that. And then there's another volume down here for WordPress itself. There's another volume claim, also 20 gigabytes, and there's the storage class. So I'll spare you the details, but let's just go and create WordPress. So you'll see essentially the WordPress pods come up. You'll see that the 2 claims have been bound, which means that a volume has actually been created, capacity of the volumes, and here we are. WordPress is running. So let's, it's important to know that this is running inside the storage. Not only is Kubernetes orchestrating the storage on the, on the consumption side, but it's with Rook, it's now orchestrating the provider side of storage. Rook is providing storage that this cluster itself is using. So let's actually hit the WordPress endpoint. 30, there it is, oops. I'm not sure what's happening here. 1 second. $39.54. And there is WordPress. I should just quickly configure it. Install it. Log in. And then let's just go to the default page. So here's WordPress running on top of Kubernetes, where the 2 volumes that it needs, one for MySQL and one for its static content, are provisioned by Rook. And just for fun, let's actually go ahead and kill one of the pods. Let's kill the MySQL pod and show you a failover case. So you'll see when I kill the pod terminates, and then Kubernetes fails it over, reschedules it, and it picks up its volume again. And if we refresh, it's still working. So it's hitting the database endpoint. And that's it. That's it for the demo. The key points here is that storage is now running inside the cluster, the storage service itself. It's self-managing through the Rook operator. It's self-scaling. As I add nodes, then the cluster grows with my apps. And it integrates very deeply. I didn't use any Rook API or Rook CLI. This is really just using Kubernetes itself and treating storage as if it was built into Kubernetes. Make sense?
Yeah, nice demo. Bassam, I just had a follow-up question. On the when you sort of deploy, the actual backend storage pods, how does it know which block devices or file systems to use, right? Presumably, if you guess the wrong one, if it's a block device or pass in the wrong path, it could be problematic. How do you guys route around that?
So basically, when you create a cluster, you can specify which storage nodes you want to use. So you can use the node selector facilities, or inside Kubernetes, you can by labels or by any other kind of metadata. You can select the nodes, and then within the storage node, you can also tell Rook in the cluster specification which devices to use, or whether you use the file system, and how to configure these devices. All of that is essentially part of the cluster definition. And you could do it both we make it easy to say, just use all the devices, or use all the nodes for storage, or you could get more selective. And if you want, you can probably go down to the level of saying, here are exactly the storage nodes that I want you to use. And you can make changes on the cluster definition, and the Rook operator will actually pick those up and in a reconciliation loop, make the changes as needed.
Okay, so if you wanted to, you could have like a topology.
You could, yeah. In fact, Ceph is really good at this kind of topology. I'm sure you're familiar with crush maps and all that. So we use the metadata defined on the cluster and the storage nodes and all that stuff to feed into a crush map, so that we can improve storage, both in terms of durability and performance of storage based on the location of the nodes and the location of devices on the nodes, or the kinds of devices on the nodes. And things like if the devices themselves, some of them are SSDs or NVMe devices versus, say, spinning disk. All that factors also into the selection criteria and how we build the cluster, and you could configure that as part of the cluster.
Thanks.
Hey, Bassam, thanks for the demo. So there's like an active design and PR going on for a Rook plugin inside of Kubernetes.
Yep.
What's the background behind that? I mean, if you just showed us a demo today that works with Ceph, what's the Rook plugin all about?
Good question. A number of things, actually. So the plugin the Ceph plugin that we are using in this demo are the RBD, Ceph RBD plugin, and also I think we will support the Ceph FS plugin. Three things that motivate a new plugin. One is that the path to actual disk, the storage node today goes through the kernel. So you think of a pod mounts of, there's a volume mounted, and then we do use kernel RBD going down to the kernel, and then to the actual storage cluster itself. There's a desire, and in fact, even the Ceph team and others, there's a desire to run that body of code in user space for numerous reasons. One is you can bypass the kernel and get RDMA and everything else. The other is that a less obvious one is that the actual versions of kernel RBD and kernel CephFS are quite lagging when it comes to kernel versions, because the code gets checked into the Linux kernel tree, and so there are known bugs and timeouts and issues in previous versions. So a typical thing that we'd like to do is basically use things like iSCSI or NBD to mount the volume, but have a daemon set running that's actually proxying in user mode to the cluster. And that decision we'd like to be dynamic, not happen at, say, cluster definition time, but at actually runtime, and actually base it on the capabilities of the nodes itself. There is also the issue of that today, when you want to use the kernel RBD, or you have to use a bunch of tools that have to be installed on the host. And that's problematic for many deployments. In fact, in some environments, like cloud environments, you can't even run those without having to build your own images, and et cetera. And then there's the final issues around supporting read-write many and the fencing that happens around that. There's a desire to, like even in this case, the WordPress and MySQL case is a good one, because you'd like it so that you have multiple instances of MySQL sharing a volume, but only MySQL will actually sequence that themselves. Only one of them will write. So you can have the fencing happening at a higher layer to support even a quicker or more of an active, passive failover scenarios. Does that make sense?
That functionality is not functionality that the general Ceph driver would want to introduce?
Not without, you'd have to do fencing outside of it. The current implementation does the fencing within the volume itself, within the Ceph functionality itself.
Yeah, today you get an RBD lock, Clinton, where
that's right.
So basically, when the volume plugin mounts on a Ceph read-write once volume, which is an RBD, that attach will then lock that RBD volume to that host. So it's all happening at the volume plugin layer, but there's no fencing that happens for the read-write many stuff, as with pretty much all our read-write many.
And that's exactly right. And depending on the kernel version, KRBD version that you have, fencing may or may not work. I think for it to work really, really well, as intended, you have to have like 4.11 kernel or newer. And so, part of the strategy that the Ceph team is doing as well with this is that they're essentially trying to build, through iSCSI, or NBD, trying to move that all into user space. And so, rely on some primitive protocol like NBD to do the actual volume mount, but move the rest into user mode. And there's actually, intuitively this might not make sense, but if you get into really high-end networks, there's actually performance reasons to do that in user space as well. Because you can bypass the kernel network stack and just go directly to devices. And so that having that logic and that decision happen more dynamically or at runtime is outside of the scope of the existing RBD and NBD plugins in Kubernetes.
Okay, thank you.
I had a quick question about how do you expose block devices to the pods themselves? Are you using a host path or something else?
To the storage pods side?
Yeah, yeah.
Yeah. So right now we're using host path. We're about to switch it all in 1 second to a local path or um,
Local storage.
local storage. Yep.
Cool.
And that's a really great facility for this use case because it's
Yep.
we don't have to deal with like which directory was it on, and we currently create affinity between the Rook OSD, the storage node, and the machine that it's on, so that it can come back in the same place. So a lot of things get easier with 1.7, and of course we'll have to be backward compatible with 1.6. But this work is targeted for our 0.06 release.
Cool.
Any other questions?
Hey, Bassam, this is Ben. Are you going to go into any more details on, what Rook is doing, what the operator's doing, the architecture of those pieces?
Yeah, I have a slide on architecture. I'm happy to walk through it. Let me see if I can bring that up. So I think we're done with the demo. I can go back to the slides. So currently, we currently support 2 modes, and I'll just talk about one of them for now. The Kubernetes implementation essentially runs like a Kubernetes controller. So if you're not familiar with controllers, it's essentially there's the concept of a desired state, what the admin or cluster operations or cluster admin wants to happen. It's a desire for something to happen in the cluster. And there's the actual state of what's actually in the cluster. And a controller essentially just sits in a loop and tries to reconcile, actual state with desired state. So it's so when you saw the declarative statements to create a cluster, there was a YAML file for the cluster, and the operator is watching. It watches the Kubernetes API, so you'll see, and it'll find that there's a cluster, a new cluster, and it'll go do what's needed to bring the cluster up. If there are changes to the cluster, then the operators will probe the actual state, and make appropriate changes, mutations to the cluster itself. So it's literally implemented as a controller, where it uses the Kubernetes API to watch all these objects, really these objects defined here, and it itself uses these objects to create, to actually deploy the cluster and run it. So for some of them, you can think of them as input objects, and for others, it's actually using them. They're output objects. And the controller has all the logic for, the custom logic that applies to the storage system itself. So it's got all the business logic, if you will, around what it takes to run Ceph in this environment, and how to keep it healthy, and how to scale it, and how to bootstrap it, and all the quirkiness around that. And then how to effectively deploy its resources and use the storage nodes, and dealing with upgrades, dealing with all that logic of running a storage service at scale, lives inside the Rook operator. And when it's doing that work, it's talking to the Kubernetes API and creating deployments and daemon sets and pods and services and everything else as needed to do that. It also talks through management and health API to each of the pods themselves. So this is at a node level, not cluster level. If I need to probe a given storage node for its health, or I need to probe a given storage node, or ask it to do something that is a node level operation, that happens between the operator and the actual pods themselves. And sometimes that's done over, our an API to a node level API in the Rook pods, and sometimes it happens over, say, a Ceph level or whatever level API that happens there. And the pods themselves are, containers that run in they're streamlined containers that run in this environment. We follow an approach where we now have just a kind of like hypercube. We have a hyper Rook pod that has it's about 100 megabytes compressed. It has all the logic needed to run the entire storage cluster, and it can come up in different roles. So it can come up as a Ceph monitor or a Rook role, including the operator itself, is deployed in this way. And then the rest is really, with this design, this is the very integrated design into Kubernetes. We've shied away from exposing any kind of API endpoint for Rook or at the cluster level, or any kind of CLI or anything else. The goal here is to integrate deeply with the environment. So you'll see things like, I don't need a credentials to connect to Rook. We're leveraging the security model in Kubernetes, including RBAC. So as long as you've set up your security, your RBAC policies correctly, the cluster admin will have access to Rook. It also means that if you want to enumerate clusters or you want to enumerate pools or do all that stuff, they're all objects that you can enumerate, you can list, you can, all your existing monitoring systems, all your existing scripts and all that stuff should work nicely with all of it, because there's not a new thing. It's truly an extension of Kubernetes. The last thing I'll say is that Rook itself keeps state. It needs state to manage the cluster. And by storing all of that in Kubernetes, it also gets, it essentially gets stored in etcd, and essentially all config and cluster management state is all in the same place with the rest of the Kubernetes state. So that's from a backup and DR story, that's a nice property as well.
Yeah, Bassam, just one of the open questions I have, just community discussion here, is like so the local file and block persistent volumes and the updates to the scheduler that will occur because of that, right? So basically, hey, I'm going to go into Kube and register all my persistent volumes that are local, whether they be file or block, so that they're, discoverable by the scheduler, and then basically have a stateful set that says, look, I'm going to go deploy some sort of data store. Could be Cassandra, it could be, Rook, could be Gluster or whatever.
Right.
And then you just use a stateful set that basically consumes from a storage class that is pointing to those local file or block PVs. I think it's kind of interesting at that point, beyond the monitoring, management, and health API, I get that's different. But like from a deployment standpoint, how much we will need operators going forward, because the stateful set will basically handle the deploy. It'll also, with forgiveness and things like that, be able to handle loss of nodes, recovery, things like that.
I strongly believe that you need operators for storage services. I mean, we're building operators for things that are much easier services, like even, there is very specific business logic that's related to running a storage service like this. I mean, think about doing an upgrade. I'll give you that. That's a one that makes a lot of sense, especially an upgrade that requires a disk format change, right? You'd want to sequence that such that you want to minimize downtime. You want to do this as close to being online as possible, right? And to do that, you basically have to have logic that says, look, I'm going to upgrade 5% of my data at any time, because I don't want to risk having any kind of vulnerability where I brought a bunch of nodes down and then I have a failure, and then I'm now looking at data loss. So those kinds of scenarios and that kind of logic, just as an example for upgrade, require a very smart operator that it can orchestrate that kind of upgrade. That's well beyond the scope of, say, what the stateful set would do. I mean, Kubernetes is great. It has a bunch of controllers that try to make tasks like stateful sets or deployments or replica sets or all that stuff useful, but it is not all of those apply directly and are a good fit at this layer. They are useful at a lower layer, and the Rook operator uses them. In fact, we use things like replica sets and daemon sets and all that stuff. But when you have specific logic that's related to your service, I don't see a way around writing that logic inside an operator. And storage services are probably the hardest ones from if you look at because they are stateful and because they require, and they're so finicky about upgrade paths and how much of the data you're touching at one point and placement of things. I mean, all of that stuff is really complex and requires custom logic beyond just primitives built into Kubernetes. Another good example, if you want to follow, is why is there an etcd operator, right? And the reasoning is that if you break quorum in etcd, you're kind of screwed. So that's not something that a stateful set understands. Right? It's something that requires probing each of the etcd leaders and making sure that they you maintain quorum while you are doing an upgrade. That problem is amplified at storage services like Ceph.
So Bassam, I think one of the things I'm thinking about here is that Rook is essentially a control plane abstraction above Ceph and other platforms, and it looks like it's actually for possibly more than just control plane in some aspects of where it's going. But in terms of operators, wouldn't it make more sense to augment the existing operator interfaces and to make some of what you're describing in terms of what these common needs are for managing the lifecycle of these storage platforms, like bring those straight into the Kubernetes platform and then have a extensibility layer that hooks natively into storage platforms versus having an abstraction above any of the storage platforms in the long term?
That's a good question. I think some of it will actually come down to Kubernetes. I mean, if there are some patterns that emerge where, say, stateful sets can do, if we add one more feature into stateful sets, then they could do something that a bunch of operators or a bunch of controllers can leverage, then I absolutely think we should push them down into the Kubernetes layer and others. And I think where it starts to diverge is when you have a logic that's specific to a given service or a given app, if you will, and that becomes harder to do. I mean, and that's but having if you think about it as a layering, then hopefully there will be enough primitives at the lower layer to kind of help build the layers above. And I think that's already the case right now. There's definitely room for iteration and improvement here.
Yeah, no, I think it's an interesting area. My team did one specific to Scale.io, which is the Dell EMC software platform similar to Ceph. And but that tends to be how this stuff starts. You build out the capabilities and you build them out for a few different platforms, and then you try to converge them under one project or interface and figure out if there's commonality, and then figure out how to drive that architecturally in the right place. So it's very
we actually started a project called Operator Kit that is an attempt to kind of generalize some of the patterns we're using for operators, and we're hoping to work with others on this as well. So I mean, have a look at it.
Okay.
Any other questions at the architectural or level, design level?
I have one question for you, Bassam. What do you see as the roadblocks to being able to extend this beyond Ceph?
Really manpower and skilled folks that can help with this. Ceph is actually one of the harder ones, I think, because Ceph is a complicated system. It's a very powerful system, but it's also very complicated. I think we've certainly had people express interest in other systems, even things like HDFS or Gluster come up. There's a lot of patterns here that I think would make this interesting. patterns that we've already addressed with Ceph that would make this kind of easier to repeat with other systems. But it's really just, at this point, community involvement and getting more people involved. The other thing I'll say just on that, like with block storage, I think, block storage semantics are kind of easier to normalize. You need to take snapshots and you need to support all sorts of things at the block level. But when it comes to file systems, and actually the same is true with object storage. As long as it talks S3, then you can do object storage, and it has a bunch of facilities. With file systems, people are quite picky about which file system they use. ACL management and semantics, how POSIX compatible are you, and all that stuff. And so I think there is room for supporting multiple storage services in this way.
Hi, Bassam. Can you hear me okay?
Yes.
This is Luis Pavon from CoreOS.
Hi, Luis.
How you doing? This is a great presentation, and I am all for this technology, absolutely. And one of the things that kind of interesting to me is the how last time you and I talked, Rook was specifically for the Ceph, but now you're saying that it could be possible to use for other storage systems. And how does this compare to, for example, the Quartermaster project?
I think if you think about, the way that Rook is implemented is that we're not actually trying to abstract all the different storage systems, but we're trying to orchestrate them. So there's not a uniform interface that says, let's do, deployment, or let's do, this cluster definition applies to all storage systems. In fact, it's the exact opposite. We're saying, let's expose what the actual storage service wants to expose, but there's no unification of them. What is interesting is using common patterns and common code to help deal with things like upgrades and versioning and lifecycle management and all that stuff for the different storage system. That there is commonality there, but it's not an abstraction on top of the different ones. So I think that comes across as a difference. I'll also say we've really only focused at this point on Ceph and Kubernetes. So it's, we're being asked to kind of go and add support for more, but it's early days. And I would hope that, Luis, you and others we could figure that out all together.
Absolutely. I'm telling you that I was, going through the slides about containerized storage and living in Amazon, and I think that's great. I think that's great.
Thanks, Luis.
Maybe one more thing. So the Kubernetes plugin for Rook, that is an abstraction over all the storage platforms, right?
Abstraction. Well, right now it's the intended goal for it is to essentially, we're working with the SIG storage on this, essentially create a volume attachment object and let the controller deal with deploying that. And we're hoping, I know Saad and I need to catch up on this, but we're hoping that this pattern of, essentially a controller-centric pattern for creating attachments and how it relates to CSI can emerge, and that we can have some good discussions around it.
Okay, thank you.
Folks, have any other questions?
Okay, I mean, I have a couple of slides left, but otherwise, this is a community slide. I think you guys can see it. We're very happy with the traction. It's getting Rook is getting a ton of traction right now, and we're happy with it. And we're hopeful that you guys, people on this SIG could help as well, help grow it. It's an open source project. We'd like it to do more. So please come help us. And then, I think Ben mentioned earlier that Rook and the CNCF are kind of trying to figure out this is a good fit for the CNCF. the Rook is actually quite well aligned with CNCF. It's container package, it's microservice oriented, and it's dynamically managed itself. But it also has it's very complementary to other CNCF projects. So it's deeply integrates into Kubernetes, and we expose Prometheus endpoint or metrics for all of the storage systems, or the storage stuff in this case. And then, building integrated storage into the cloud native stack, I think is going to unlock a bunch of powerful scenarios around federation, portability, and multi-cloud. So we think this is a good fit. And that's it. Any other questions, high level concerns, thoughts? Great. Thank you, everyone. We're, I think, right on time. So
yeah, this is perfect, Bassam. Thank you so much for presenting today, and thanks everybody for asking great questions and us having a great discussion. If there's no more questions, we can end early and see you guys in 2 weeks. And I think the plan will be we'll hear from the OpenSDS team then.
cool. Thank you, guys.
Thanks, everyone.
Take care.